Hello, I'm Richard Manley, Chief Sustainability Officer at CPP Investments. I'm delighted to welcome you to my conversation with renowned climate scientist Johan Rockström. We've all witnessed extreme weather events become more frequent and severe. In 2024 alone, natural disasters claimed thousands of lives and caused over $320 billion in economic losses globally. At CPP Investments, we're focused on ensuring physical risk is reflected in the base case underwriting for high-risk assets. And I can think of no one better to discuss physical risk with than Johan. He's a professor at the University of Potsdam, co-chair of the Earth Commission, and chief scientist at Conservation International. He also pioneered the Planetary Boundaries Framework, which defines safe limits for human impacts on the planet. He was recognized for this work last year, receiving the 2024 Tyler Prize for Environmental Achievement, often referred to as the Nobel Prize for Climate. So let's dive in. I'd like to take a step back and orientate our audience towards the realities of climate change. Really, the way to frame this is relative to where they thought we would be today 10 years ago, where are we and what have been the most significant surprises in terms of human impacts on our planetary systems over that decade?
Yeah, so if you think back in 2014, 10 years ago, we had actually, barely reached 1 degree Celsius of warming, but also very significantly, since 1970, all science showed that, yes, we have verified that humans are causing global warming, but we also showed that was a linear relationship between more greenhouse gases, so more carbon dioxide from burning coal, oil, and gas, and methane release from livestock and fertilizers, and nitrous oxide from industry and exhaust from transport and also from agriculture, having a linear relationship between more greenhouse gases, more warming. That has basically been the relationship that has configured all the climate models, been translated to climate policy, given us the global carbon budget. But what we see from 2014 onwards, so just this last decade, now that we meet in 2024, is unfortunately that we have miscalculated the strength of the Earth system. We see an acceleration of the warming over the past 10 years. So if we follow the pace of 0.18 degrees Celsius per decade from 1970 to 2014, which has guided all the policies that we are today basing our actions on, the last 10 years it jumps up to 0.26 degrees Celsius per decade. So scientifically, if you ask about the last decade, we have to unfortunately admit that we've underestimated risk, we've underestimated pace of change, and then we see larger physical risks and physical impacts. So the frequency of extreme events, the amplitude of extreme events, and here we're talking about hurricanes, fires, heat waves, droughts, disease patterns, are increasing faster than we had expected, and therefore also costing more. I call this the planet starting to send invoices back to the economy. So we are in a situation in 2024 of an even more serious challenge than we had expected, and then compared to what we assessed just 10 years back.
I suspect many of the people that are living in parts of the world that have already seen how bad 1.5 degrees of warming actually is, we'll probably think that 1.5 is already a very considerable deterioration in the climate risk profile of our planet. But if we overshoot, the bookends of our underwriting are 4 degrees or warmer, or 2 degrees or cooler as high transition risk. But just to help educate our colleagues, that the difference between 1.5 and 2, or 1.5 and 2.5, what are we really talking about in terms of quantum of deterioration? And then you introduce this notion of tipping points. And I think there is an assumption that this is straight line, and that there isn't maybe a full appreciation that losing, for example, an ecosystem like the rainforests or like the ice shelves could dramatically amplify the pace of change. and make it much harder to come back from a period of overshoot. So you would talk to just those in the order you prefer, walk through tipping points and what are they in practice and how do they change the risk profile, and then 1.5 degrees, it looks as though it's probably now going to be breached. But if we were to see that 1.5 become 2 or higher, what does that really translate into in terms of delta in risk? Because I'm going to speculate it's quite considerable.
Yeah, thanks, Richard. I mean, these are really fundamental issues. And let me see if I can tick off actually 3 important insights. I think one is, what is 1.5? Number 2, tipping points and the risk profile. But also, I think it's really important that, all stakeholders, but certainly you who work in finance and in underwriting risk, to distinguish between what I call fast variables, fast risks, and slow risks. And I'll come back to all 3. So number 1, I think it's really important, so fundamental, that science is absolutely clear today. There's unequivocal evidence that 1.5 degrees Celsius of global mean surface temperature rise is a big number. It's a very big number. And it's not a goal, it's not a target, it's a physical limit. Go beyond it and risks increase very rapidly. And to give you the quick summary of the evidence there, when you look back in the paleoclimatic evidence we have today, basically the journey of planet Earth, if we take first the last 1 million years, and we have very high degree of precision over the last 1 million years from ice core data. So over the last 1 million years, we've gone through somewhere between 6 to 8, depending on how you define them, deep ice ages, and therefore 6 to 8 so-called warm interglacials. So we have 100,000 years on average of deep ice ages. That's minus 5 degrees Celsius of global mean surface temperature rise, and 15 to 30,000 years of interglacials. And these are the warm periods. And when we now look at the data, we see that we've never exceeded 2 degrees Celsius at the warmest point. And when we leave the last ice age, 18,000 years ago, and enter the last warm interglacial, the so-called Holocene, the last 12,000 years, which is the period when we've developed civilizations as we know it. And it isn't until we enter the Holocene, the last 12,000 years, where things settle down within an extraordinarily stable, low climate risk regime, which is a 14 degrees Celsius planet, plus minus 0.5. 0.5 for the past 12,000 years. We are all dependent on this stable, harmonious, what I call the Garden of Eden, the Holocene stability domain, with a maximum variability of 0.5. So today, at 1.25, we are already at the warmest temperature on Earth over the past 100,000 years. And if we reach 2 degrees Celsius, we're on the warmest temperature on Earth over the past 1 million years, 2 million years, even 3 million years. So that's just a way of explaining where science is standing today, why I can say without any hesitation that 1.5 degrees Celsius is a big number. It's way outside of the Holocene. It's the highest level of tolerance that we estimate today scientifically that the planet can cope with and still remain in the stable Holocene-like state. Go beyond 2 degrees Celsius and we're outside even of the Quaternary. We go into uncharted territory. So that's one piece of evidence. But the second piece of evidence to, so to say, really hammer home why we should do everything we can to hold 1.5 is tipping point science. So we understand today that our planet, Earth, our home, is a complex self-regulating biogeophysical system that is characterized by interactions between the spheres, between the biosphere, nature, in the ocean and on land, between the ocean system, the hydrosphere, the lithosphere, the whole geology and soil, and the cryosphere, the ice sheets on planet Earth, and of course the atmosphere. Now these systems have tipping elements, and we've identified 16 biophysical tipping elements within this interactive sphere that fulfill 2 criteria. One is that they contribute to regulate the climate system. But the second criteria is that they have multiple stable states separated by tipping points. So you have the big ice sheets, you have the big biomes. Push them too far, and they will cross very distinct, razor-sharp points where the feedback dynamics shift from one state that keeps them in the Holocene state, like a healthy rainforest, but push them too far, and the system will flip over. Feedbacks will change direction 180 degrees, and the system goes from self-cooling to self-warming. So a rainforest can tip over from self-generating rainfall, which is the feedback that keeps the system in a harmonious rainforest system, cut down too much forest, too much heating, leads to droughts, too much fires, and the system shifts over to lose that moisture recycling capacity, the feedback, and it becomes self-drying instead, and you turn that into an arid, progressively an arid savanna-like state. Same with ice sheets. A permanent ice sheet is a white surface, and it's a high altitude. We tend to forget that the Greenland ice sheet is 3,000 meters of ice. It's cold up there. It's like walking up a mountain. We all know it gets colder. It's a white surface. It reflects 90% of incoming heat back to space. It's a self-cooling system. That's the feedback. When this system melts, it gets lower and lower. It's like walking down a mountain. It's get warmer and warmer. And at a very specific point, it starts self-warming instead of self-cooling. The surface gets liquid. A liquid surface is darker than an ice surface. And at a very precise point, the albedo does not reflect more than it absorbs, and the system absorbs more heat than it sends back to space, and it becomes like going from a white car to a black car. It becomes a self-warming system. That's the tipping point. This is what we are looking at across all these 16 systems, and in 2022, led from us here at the Potsdam Institute, but also with colleagues at Exeter University, we published for the first time an estimate, a risk estimate, of at what temperatures are these 16 systems likely to cross their tipping points. And 5 of them are now assessed to likely cross their tipping points at 1.5 degrees Celsius. And we're talking about the following 5: the Greenland ice sheet, the West Antarctic ice sheet, abrupt thawing of permafrost, which is a self-amplifying release of methane and carbon in the Arctic region, the Barents Sea ice, and all the tropical coral reef systems on planet Earth. 5 big systems. Just those 2 ice sheets hold 10-meter sea level rise. And of course, cross a tipping point. So that comes to my final point on distinguishing between fast and slow variables. Crossing tipping points can lead to abrupt change, but most of them lead to slow change, but it's irreversible, and the rate shifts. So, for example, currently, we are in a situation where we are increasing sea levels due to global warming with somewhere, between 2 and 3 millimeters per year. And we've so far increased the global sea levels with roughly 25 centimeters. If we cross a tipping point on the Greenland ice sheet and the West Antarctic ice sheet, it wouldn't be a tsunami. We wouldn't get 10 meters suddenly just flooding in coastal cities around the world. But what would happen is it would be unstoppable. We would press an on button and we could not turn back. We would simply hand over to our children and all future generations a planet that would irreversibly land at 10-meter sea level rise. So that's one, I would say, moral climate physical risk. But secondly, it would lead to a change in the rate. So it would go faster. So instead of being on a pathway, according to the IPCC, leading to 1 meter sea level rise on average this century, that's the path we're following, we are at risk of following a path that would take us to 2 meters by the end of this century. And then, of course, ultimately 10 meters. So crossing a tipping point is a slow variable, but it's serious because it's unstoppable and it leads to a rate change. We kind of accelerate the path in the wrong direction. And if we can factor in the responsibility on the long term, then of course I would argue that the physical risk is then increased. So I would place extreme events on the fast variable, droughts, floods, heat waves, fires, that hits us immediately. But crossing tipping points are more likely to be in the slow variable side. And it's almost a question back to you, Richard. How do we factor that into the physical risk assessment? That's one of the challenges we're facing.
Yeah. And ultimately, the conclusion there is if we were ever to cross a tipping point, all it will do is effectively accelerate or pull forward
Yes.
the time at which prospective damage forecasts start to impact the economy. So, what I'd like to do now, if you can, is explore how we currently model the greenhouse gas emissions, changing climate outcomes, impacting weather, and then translating into economic damage to localized risks or macro economies. What's the 90-second elevator pitch as to how climate translates into economic impact?
Yeah, so there's definitely more research continuously ongoing here because you're putting your finger on one of the big challenges to, one, to map the human caused climate change, and secondly, assess the impacts and translate those into economic value or economic damage. But we've come a long way here. And what we do is that, number one, of course, increasingly we can validate our climate models on climate risk with observations. So that is actually something that gives us a lot of reassurance that we today have so many satellites and so much Earth observations at such high resolution that we get a really, almost real-time assessment at the local level of extreme events, and we can plug those into the models and get the attribution assessment clearly done. And this can then, and it is then, connected to so-called damage functions in our climate economic models, which is something that is advancing, by the day. And we quite recently published a paper showing that we are already today committed to climate damages to the economy based on the global warming that we have already in the pipeline, corresponding to a 19% reduction in global income levels by 2050 compared to the business as usual trajectory of the global economy. So we're talking about a 38 trillion US dollar decline in the size of the global economy by 2050, just on the impacts that we project today. And I can reassure you, Richard, that this is still a quite conservative, or not quite, it is a conservative assessment because it only incorporates, because we haven't been able to come further, labor productivity decline because of heat. So it's very much focusing on the impacts of heat on labor productivity in the economy and the impact of extreme precipitation events on infrastructure. But of course, we know that you have other feedbacks on health, on disease patterns, tropical disease patterns expanding across, unexpected geographic or societies around the world. We have more and more evidence that climate change impacts on fresh water availability, which impacts on food security, which then impacts on poverty levels, which can lead to displacement, migration, and even amplify risks of conflict, even armed conflicts, not being a direct cause, but being an amplifier of risk. We see these trends in Chad, in Mali, in Syria, in Sudan. These are indications that the climate economics may be, very likely even more severe than the assessments so far. So I think we're standing on a very solid ground today to say that already today, we're in the midst of the climate crisis. It's already today a factor we have to place right at the center of climate risk assessment, on physical risk, but also on impacts on humans, on human health and human security.
And you just highlighted there, and I think just to reiterate to the audience here that the models we have today are informed and learning from relationships we have encountered today between climate and economic outcomes. And we can make assumptions about how they will change over time, but there are some where there could also be market tipping points. So you touched there on the notion of migration. I think a study of recent migration from Africa and the Middle East into Europe can actually quite easily be attributed to the impact on agriculture of climate change in those regions. To date, though, the numbers have been relatively limited. It is now in the millions, but it's not in the tens or hundreds of millions. Most macroeconomic models will actually assume that migration could be positive to the economy of the recipient nation. That's in the tens or hundreds of thousand order of magnitude. We could clearly be looking at bigger migration outcomes were we to encounter some of the worse outcomes. The other one, though, that I suppose keeps up at night is there is an assumption, I think, embedded today in the models that the capacity in the insurance market will be able to expand to continue to meet the market's appetite to transfer risk of climate impacting businesses. And we are already now starting to see some insurance markets dislocate. Insurance is a tough one because it's often a covenant concern for debt. It's often a requirement even to operate businesses. But maybe just without necessarily giving a preview as to how they might impact the models, you just walk through which of those kinds of behavioral tipping points or market dislocation tipping points, if any, are captured in the models, and how would you anticipate their ultimate incorporation either accelerate or dampen the assumptions we make on economic impact from a warming climate?
Yeah, well, to begin with, I think one has to be quite honest that the large global climate models that inform, for example, the safe pathways to be able to hold 1.5 and the scenarios that build the IPCC models, they are not very well configured to also include impacts on uninsurable assets, for example. So I mean, in the models, we're still, let's say, struggling with this, and that is definitely one of the challenges. On the climate impact mapping, we here at the Potsdam Institute, for example, we support the IPCC with a program called EasyMIP, which is the climate impact assessment mechanism, and there we are getting better and better in being able to also assess risks of uninsurable physical assets, and it's largely related to coastal zone impacts related to sea level rise and big surges of water related to storms. But also what I foresee, I mean, I'm saying this is still something that is work in progress, is exactly the point that we touched on, which is freshwater related abrupt changes in food security. And the reason why this is such a central factor is that we know that, for example, in sub-Saharan Africa, over 95% of agriculture is small-scale rain-fed agriculture in already vulnerable regions, hydroclimatically vulnerable regions. And when that is reinforced due to climate change, it's not difficult to tip these over very rapidly, causing potentially, as you flagged, an underestimate, particularly on displacement risks. And how that links to insurance is a very delicate question, but it's definitely a risk of large societal shifts. And we need to bring this much more closely into our risk assessments. I foresee that in the 7th cycle of the IPCC, we'll see more on integrated risk assessment than we've seen. I mean, it's really a moving in that direction, and I think we have had a lot of help also from insurance companies and financial risk assessments that are demanding that kind of science much more prominently.
Okay, maybe changing tack now and bringing this back to some of the things we're doing. So embedded within our climate commitment, one is that we will hold our portfolio company boards to account to ensure they consider the policy guidance enshrined in nationally determined contributions into their corporate strategies, and also proactively identify physical risks and seek to abate them. We are making investments in solutions and scaling green technologies as they become economic, and also actually supporting investment in grey sectors of the economy to support their decarbonisation. So those would be the governance actions we're taking and the investment actions we're taking. I talked to how we seek to underwrite our base case to consider transition risk and physical risk. But what other things do you envisage that investors will need to be doing or could actually dial up their focus on in order to contribute proactively to both confronting the transition challenge we have, but also seeking to ensure that their investments are resilient to the physical risks that we may encounter over time?
Yeah, no, I think, well, to begin with, I'd like to commend all the work you're doing in this area. And I think the key entry point to try and answer your question is your final word there, resilience. Because I think we're seeing, if you look at the direction of travel, it is that it is really good. I support companies focus on climate, but we also know that we have many other sustainability challenges. However, we also know that the only way to solve the climate crisis and to reduce physical risks and unmanageable outcomes of both abrupt and slow impacts like crossing tipping points is that we also incorporate scientifically based quantifications of boundaries or targets beyond climate only. And the reason for this is resilience. That we today, for example, can say with 100% certainty that even if we are able to do everything right on mitigation adaptation in the energy space, we will still fail on keeping ourselves close to 1.5 degrees Celsius unless we also come back into the safe operating space on the planetary boundaries, on biodiversity, on fresh water, on land, on nitrogen, phosphorus, and air pollutants. And these are what I call the biosphere boundaries that determine the resilience of the planet. So we come back to this discussion of that there is no reduction of physical risks and manageable levels for both insurance and being able to financially underwrite investments unless we also keep the buffering capacity in the ocean and on land as intact as possible. And that requires investments in resilience. And I see this being definitely a way forward to put it simple, that we all need to become stewards of the entire planet. Even if we care only about economics and climate, you still have to, so to say, address the planet. And moving along those lines of quantifying targets beyond climate, I think is one really important step forward.
Okay, wonderful. We are getting close to the end, unfortunately. I have two more questions for you. We've talked about the science. We've talked about the transmission of the science into the economy. We've talked about the role that investors can play in supporting what needs to be done. But we're just one part of a solution to system change. And this is a system issue. It probably needs a system solution rather than just the support of the financial services sector. Where do you see other actors in the economy as needing to support the decisions, the actions that need to be taken to both confront the immediate need to slow anthropogenic emissions, but also ensure that we build the resiliency for a prospectively warmer world?
Yeah, that's an easy question. Well, to start with, I think it's really important that we recognize the fact that we are in a situation of urgency, and that we need to have business, finance in particular, policy and science, but of course also citizens, to sort of say collectively embrace the fact that we have a point of urgency and that we have to step out of our comfort zone and set quantitative, legally binding regulatory means that we need to keep ourselves within. So I'm for example, strongly in support of scaling a price on carbon, correcting the market failures. We cannot continue allowing ourselves to destroy the stability of the climate system and quite frankly, the stability of the planet by subsidizing unsustainable investments and economic developments. So that's kind of at the highest level. But then bringing it down one notch, I think what we see not least in the recent elections in the US, but also in the instability in many of the economies, also in Europe right now. I mean, I'm sitting in Germany where we have another government crisis, which has a lot to do with the transition from a fossil fuel-based driven economy into a green, renewable energy driven economy, and how to handle this in terms of the economic decisions. And I think this proves one important point, that the only way to succeed with the systems transition that you're referring to is that we can provide a clear, convincing narrative that the sustainable options are the winning outcomes. Winning in terms of reduced risk, in terms of economic competitiveness, in terms of jobs and social security, and of course in terms of attractiveness and modernity and secure health-wise for humans. Today we are failing largely because nobody really, truly wants us to remain in a coal, oil and gas driven economy because they love coal, oil and gas, but it's because they perceive that to be the cheaper and more secure option for the lifestyles we have today. And we have to enable the sustainable pathways to be the more attractive and more winning pathways. And that's where I think that pension funds and asset managers and financial institutions that determine where we place the capital upfront for investments in the next technology developments need to be, very, let's say, provide the leadership to be courageous enough to place the bets on the sustainable options, because we've come so far that we can today prove that these options very likely give us a much, much more competitive outcome. And that is proven today when it comes to renewable electricity production, electric mobility, sustainable health of food production, green construction, design of urban space, sector after sector after sector. We today have evidence of scalable solutions, but still we're not able to get the finance to move in that direction. And even when we get the finance in that direction, again, look at the US elections here, where we have the IRA, which is a huge package of public funding going into support of green technology transitions. Still, it doesn't move the dial on creating the confidence that the pathway away from coal, oil, and gas is the pathway to the new, more competitive, attractive modernity. And so here I think we in science cannot resolve that, and no stakeholder can do it alone. But I think that's the systems transition where the financial sector can play a particularly important role.
Well, sadly, Johan, with that, our conversation has come to an end. So thank you for all of your time. Thank you for your leadership on this subject. And I look forward to continuing the dialogue.
Yeah, same here. Thanks a lot.
Thank you.